call this the Zero Downtime Bypass Setup, the ZDB, the ECT ZDB. Let's take a look at it. It's built in two sections. Here's the power section and the VFD section. Let's take a look at the face. We got your circuit breaker disconnect, main circuit breaker disconnect with lockout and tagout, of course. Okay, you've got your basic switches here, which you can switch from bypass and VFD online. This can be automated. There's a lot of options for this thing, but this is just the basic setup. We got these really cool keyed locking, as a standard feature, keyed locking T-handles, which really is kind of nice, easy to keep people out. Okay, but the most important feature, one of the most important features, is this VFD disconnect. Okay, which is again lockout, and you can lock and tag this out, which is important. But when you kick this on, your system can be off. You can power up your drive, program the drive while the whole system is down or in bypass. And then when you're ready to kick it over to VFD online, you can do that on the fly if you want to. But bottom line is that's like a test switch, also a disconnect. It's important. Let's shut that down. And so let's take a look inside the power section first. Let's take a look at the way it's constructed. There's a wall here separating the VFD, completely isolating the VFD section from the power section. Here's the 460 volt coming in, 110 volt control transformer. I threw a line reactor in here. You can put EMI filters in here. You can put temperature control in here. You can put PLCs and all kinds of control in the power section. Again, the power section completely isolated away from the VFD section. Here's the bypass contactor and the drive contactor. And then there's the VFD disconnect. Now when you disconnect the VFD, you also are disconnecting all the 110 that feeds the ventilation system into this panel. So this panel, this section, the VFD section, is completely dead when this VFD is thrown. That's key. Here's some terminals for the remote bypass start and some interlocking terminals. These are the 110 terminals. Again, these are finger safe. And of course, here's your overload relay where you connect your motor up right here. Now let's go into the VFD section of the panel. First thing I'm going to do is I'm going to shut down the VFD. Knock that down. I'm going to lock it. I'm going to tag this out. Okay, and I'm going to get in this panel here. Oh, I can't get in. It's the keys lock. I can't get in this panel. Oh, that's right. I got to use a tool. Got to use a tool to get inside. Makes it a little more difficult to get inside. We'll use a tool. Now we'll get inside. Here's the VFD section. And the ventilation system, the vent fan, NEMA 12 filter. The temperature controlled, so the fan is operated by a temperature control. When it heats up in here, the fan comes on. That's important stuff too. And here's some terminals. I brought the terminals, the most important terminals: run, stop, speed reference, and interlocking terminals. Down from the VFD down to a terminal board. Makes it nice and easy to hook up. And then I've got some finger safe terminals for the input power and the output of the VFD. So in case you do have to replace the drive or do some repair where you have to pull the drive out, you can terminate everything back up to nice convenient terminals rather than having a bunch of wires just hang out inside there. Again, the VFD section completely isolated from the power section. So this thing could be in bypass running, and you 100% safe to either repair, replace the drive, and keep your system up and running.